Hello once again, our most valued student. My name is Confident and welcome to our revision session for grade 10, and we are looking at magnetism here, and I'm going to take you through the topic of magnetism and what you expect as you prepare for your final exams. This will make you ready and you will not have a problem when you start looking at this topic again of magnetism. So join me again, and remember, if you want to become a part of the family, it is always advised to subscribe. Become a part of us, subscribe into this channel, and then you'll never miss a video. Okay, so let's look at this. It says sketch a magnetic field on a single magnet and show the magnetic field lines. So this is important. I want to show what is just important for exams is to know how to sketch a magnetic field. So if I'm going to sketch a field, this is a power magnet. And remember, the power magnet has got two poles. There is the north and the south pole. You must always know that the charges move from the north. Let me use a different one. Charges are always flowing from the north, right? And they are always entering the south. See, from north to south, always start there. And then what you can also do, you can then have a one that is like that, but don't forget they must never cross each other. You see that? And then you can have another one. Maybe let me do it like this. They must never cross each other. And then you look at it. Where is it coming out? Remember, it's coming out from the north. See the lines to enter the south. Similarly, I can have another one here like that. Where is it coming out? From the north to the south. You can have just a single arrow like that, it's fine. Even on the other side, have another one which is much bigger, and then it's coming from north to south, and I can have another one like this. It's from north to south. This is what they mean and say sketch a magnetic field on a single power magnet and show the field lines. Are you with me? So it doesn't matter, it's the same. Even if they said you were starting with north and south, you find that you were what was it? It was a north and south scenario. You'll just do it like this. Look at this. If I can change 10 this, and then it still be the same. See, this is south, this is north. Now look at it. Your arrows now are coming out and going in. It doesn't matter whether you are north, whether you are south. You can draw it the other way around. So this is a field around. We call this the magnetic field. So these lines must never cross. Let me also remind you this. Number one, the lines never cross. Okay, don't forget that. They never. Number two, they never touch, right? So they never cross, they never touch. So those lines, must be careful that you are ensuring that you don't do that, because they will penalize you some marks. And then say sketch a magnetic field on two magnets that attract each other. So remember, when you're bringing two magnets together, there is a force of attraction. All right, if I have, for example, a magnet like this, and I have another magnet here. All right, so now if I want these magnets to attract, what will be the charges? So the moment I say north here, what will be this one? It will be south. So for them to attract, I cannot have north here. Yes, I can have actually north here, because it's north and south like that. You understand? So north south, north south. This, as long as there is a south north pole, there is going to be some attraction. So if I'm going to draw the forces of attraction, so here you draw straight lines. I'll encourage, just let's have different it's straight lines. Use a ruler, and the lines must be going in here. But remember, where did you say you move from? What you are moving from? Let me make them 3. You are moving from the north to the south, from the north to south. This is how you do your lines. Very important that. Then I'm leaving this space intentionally, because don't forget, the magnet has got its own what? Remember, like from the first magnet moves from what? From north, it goes to what? To south. See? So it's entering here. Nothing has changed. You can see that it's still entering. See? From north to south. Even on the other side, like that, it moving from north, always from north to south. You can even make a bigger one. And then here, what I want to do, let me make something much inner, like this, from north to south, even inside here. From, don't forget, they mustn't touch, to south. Even on the other side, remember, you are going to have what? From north to south. Seeing that? It's coming out from north, entering to south. And then it's coming out from north to south. You see, I'm just making them uniform, from north to south, and then from north to south. Now look at this. There's the next one down there that is important. It is the one that I want you to be careful of. Then I'll make it bigger. There is one that is moving from north all the way coming into the south, you see, of the other magnet. And the one that is moving on the other side from north coming in here into the south. So this is what we mean when saying field magnet of magnet that are attracting each other. So what are you going to be focusing on? Don't forget that one. Don't forget of the one between the two magnets, the larger field line. Then we've got the one individually, and then we've got the ones that are showing in there. It's attraction. Are you with me? So that is what you expect when you're drawing field magnets that attract each other. What about sketch a magnetic field of two magnets that repel? Remember repel? How do you draw the one that repel? What I will have similarly my magnet. There it is. Now you need to tell me now, what are the poles gonna be? This one will be a bit different, right? So if I have here my north and my south, I can't have my north now like last time. So what do I have? You oppose them. I also have my south and my north. You see, that's where there can be repulsion now. So now how do you sketch? Be careful now. How do you sketch such a bar magnet? It's not strange. So this one wanted to come out. Remember, it was supposed to attract, but because of the repulsion, you see where it's going. And then remember, it's coming out. Okay, let me just do this. Let me undo this first. Remember, we said it's coming out from what? From north, and then it's coming into south, right? So let's start that there first. North to south, it's attraction. North to south, it's attraction. Let's do it all the other side. North to south. Where is it going? That direction. North to south. You agree with me? Now look at the next one. I continue again. North to south, and you see, like that. So look at these lines, how they are doing. So it's from, okay, here I'm making an error now. This is wrong. It's supposed to be on the other side. It's north to south. All right. So look at the other ones. Also, I'll do the same. North to south, and even here from north to south. You see that? So there is this empty space. So you can even have something like this. You can even have something like that to show that yes, they are entering from somewhere, wherever they are coming from. Even these, but there is going to be that empty space. That space here will never be occupied. We call that space repulsion. Force of repulsion will be there. So there is going to be an empty space here. Are you with me? So that space, make sure that you leave it empty. So the best one that you can do is to just leave it like that. All right. That is the force of repulsion. If these were the other way around, for example, if I was to draw the north, sometimes you find other books doing it like this, where if this was your north, and this was your north. Let me make it a bit further like this, because they can say sure in this scenario where this is your south, this is your north, this is your north, this is your south. You find them doing like this in the other books. See, coming out, you see, this is north, and then even here coming out, it's more like they are bending. Remember, they are okay, let me make them proper. They are like bending as to, you see that. So what are we trying to say here? We are saying, of course, they're coming out from north to south. Look at the arrows, from north to south. Even here, from north to south, from north to south. You see that. But what we are trying to demonstrate, when you're taking it out like this and taking it out like this, is to show repulsion. See, as I said, these lines must never meet like this. These lines must never, they will never cross. So in the center here, that's what we're trying to refer. That particular center, there is a repulsion. That space must not be occupied. That's where you have got a repulsion. Alright, so just remember that. Those are the most important things I wanted to bring to you in this lesson, and also just to remind yourself to say like poles repel each other. To repel means move away from each other, and unlike poles attract each other. Now, definition of a magnetic field: it is a space or a region where a magnet or ferromagnetic material will experience force. Now, I wanted to remind you something. If I take my magnet here, for example, let's say I have my magnet which is north and south, and then I bring a nail, right? When this nail is being attracted, don't forget also it's a ferromagnet. Now, a ferromagnet is a material that can be attracted to a magnet. So when you bring it closer, it also becomes magnetized such that this pole now becomes north, that pole becomes south. So it acts like a magnet, a temporal magnet. Don't forget that. As long as this magnet is here, this will also act like a magnet. If you bring another magnet here, you will see that this will be now the north and this will be now the south. Remember, because this is now a temporal magnet. If you bring it the other way around, if you bring, for example, the south here like this, if you bring the south and the north, you will see some repulsion. Are you with me? That is that part. And then, so a definition of a magnetic field, we are saying it is a space where a magnet or ferromagnet will experience a force. And then this is what you need to know about this force. The magnetic field force, remember this word, the magnetic field force depends on distance. When the distance between the two magnets decreases, the magnetic field force will increase. And when the distance increases, the magnetic field force weakens. Meaning, what does it mean? It means when I've got my two magnets here, one is like here, and the other one is here. Alright. So, and the other one, let's do it again, is here. Alright. And the other one now, you move it further. Like this. So now look at these two scenarios. So this is my let's say my south and my north, my south and my north. So now we say it here, remember there is attraction here from north to south, right? And then even here you have got attraction, it's still the same. Okay, I'm going to make them the moment there is attraction, it means this will be north, this will be south, you see. So north and south. Now let's compare the two. We are saying now the magnetic field strength, there says the magnetic field force, this force here at this part, it is stronger. That force of attraction there is stronger. Why? Because the distance is shorter distance. Which distance are we talking about? We're talking about the distance between the magnets. That distance, let's call it D. But look at this other distance here. Look how far apart these magnets now are. So when it's like that, the force weakens. So this is a weaker force of attraction. It's weaker. Why? Because the distance is now longer. D is longer. Are you getting that? So when you bring them closer together, the force of attraction increases, or the magnetic field force, it increases when you bring them closer together. When you bring them afar, when you take them apart, that force weakens or decreases. That is a very important one. So guys, this is what I wanted to bring to you on this lesson. Now you need to join me. Okay, I think I can, before that, let me quickly do this work so that we can do the other activities later. It says in the diagram below, steel paper clips A and B are attached to a string which is attached to a table. You see that the paper clips remain suspended beneath a magnet. So these are strings here. If you can check, these are strings, but there's paper clips A and B. Then it says here, define the term magnetic field, and we did mention that it is a region or space in which a ferromagnet or a magnetic material will experience a force. There it is. Definition of a magnetic field is important. It is a region or space where a magnet or a ferromagnet, magnetic material, will experience a force. And then what is the polarity of the top end of the paper clip, north or south? Now remember I said to you, the moment you are having a paper clip closer here and you're saying it is being attracted, so obviously that paper clip on top there, since its attraction, it will have a different pole. It's now a ferromagnet. It becomes south and this becomes north. You see that? And then even here it becomes north, this one becomes south. They can even attract each other. You understand what's happening there? So on A there we said it becomes south. That's the answer. And then two power magnets are placed closer to one another as shown in the diagram below. Complete the magnetic field pattern between the two magnets. On the answer, see, they give you such, and then when you do that, you don't need to strain yourself. So what you have, remember, have first your field lines from what? They come from north to south. Always have the basics. They come from north to south. That's what they are looking at. So they need at least show two of them doing that. You know, coming from north to what? To south. They mustn't touch. And then even here, you do the same thing. They come from north to south. They come from north to south. Try to make your diagram as neat as possible. And then even this one has got north to south. Even here I can have the outside one north to south. You know, but make sure they never touch and cross. Just leave it like that. Or if you want, you can have those, but you know, as long as you are not going to make them touch, you can have those doing like that. But don't forget, they are coming in. They are coming in, and then, but I think it's now crowded, you see. So even if you left it like this, the answer was going to be fine, just like that, right? And then they're saying, if the distance between the two poles is increased, you see, will the magnetic force between the magnets increase, decrease, or remain the same? If you increase the distance, when this one moves this direction, this one moves this direction, the moment the distance between the poles is increased, the magnetic force will what? Will decrease. And then they say, explain your answer. Remember I said the magnetic force depends on distance, all right? And then it's saying the further apart the magnets, what happened? The weaker the magnetic force, the weaker the force. So you say the magnetic force depends on distance. The further apart, the weaker the force. And then you can do the opposite. The closer the magnets, the what? The stronger the force. The stronger the magnetic force. The magnetic force. So it's up to you how you want to do it. But that is what I just wanted to bring to you. There's quite a lot of activities that I still want to bring to you when it comes to these magnets from an exam perspective. But guys, you need to be a part of the family to gain more on these. So what I'll encourage you is, if you're not subscribed and you know that somehow you have been coming back to this channel, it means you need to become a part of us. Join us. There's nothing wrong with joining this 24-minute lesson. It is going to prepare you for your final exams. We have got students who have been sending me messages to say, you know what, I got my distinction now. I managed to do well in my maths. I managed to do well in my physical science. And they're doing better because they sit on this channel and ensure that every video they get for physical science, if it's grade 10, they make sure that they watch every video. Why don't you become a part of them? But unfortunately, if you're not subscribed, you'll get one video today. Sometimes you miss another video because YouTube won't notify you. But if you're subscribed, what YouTube does, every time there's a video, YouTube keeps sending you some notifications. Anyway, we've come to the end of our session. Join me in the next session where I now look at extra questions on magnetism so that you can be able to answer whatever question they throw you across you during your exam. Thank you.